Ooh, making another draft science video. Okay. Yeah, this one's a little different. I think. Let's see if we can solicit conversation with this guy. Okay. Who just posted a video on part 5, magnetism, exposing the cult of quantum mysticism and particle field fantasies. And part of me says, okay, yeah, he's ragging on Feynman. Doesn't like this quantum crap, but it's the wrong part of the quantum he doesn't like, so maybe there's some room for a conversation. Excuse me. A lot of allergy, whatever. Still fighting with this yeast thing, I think. Anyway, so it is just kind of funny that this video is horrible in the sense that he just wastes a lot of time, pointing out irrelevancies about Feynman's gestures and Feynman's this, and it's just, and he's so over the top in terms of demonizing Feynman, which I think is totally unnecessary. Clearly, Feynman said repeatedly, we don't know how it works. So, he makes an argument in here, well, it's okay not to know, it's okay. And, well, apparently it's not okay, because Feynman did say it a lot. And he just didn't care about mechanism. He just cared about the fact that they could isolate behavior, in a sense, and quantify the behavior. And that's what quantum mechanics became, is just quantifying, the big picture, rather than itemizing the little picture, in a sense. Measuring what goes into a system and measuring what goes out, and understanding that relationship, but not understanding why. So they weren't big on answering why questions, if you want to put it that way. And just that whole rejection of model making, I find unscientific. And the idea that it's not possible, that we can't know nature's secrets kind of attitude, I just thought was not very scientific. And what he was basically saying was, I can't figure it out, so you can't figure it out. I'm really smart, Einstein's really smart, we can't do it, you can't do it. That attitude needs to be ridiculed, and maybe even mocked. But this, again, is way over the top. And, particularly because this is the magnetism video, where Feynman is trying to explain that you really can't explain some things without going really, really deep. You just can't, because it's like you could explain a magnet by talking about little magnets inside of the magnet. And that's the irony here, is this guy's counter theory is pretty much just that kind of bullshit. It is just replacing the big magnet with, well, there's all these little magnets inside, or this magical force. No explanation of what do you mean? It has a a flux, and it has a field, and it has and none of that's explained as what's it made out of. What do you mean? So he even mentions spooky action at a distance, as if it's a real phenomenon, like something's really communicating faster than the speed of light, when we know that's not what's happening, because it'd be like it's like, they use the excuse like, well, you can't really use it to transmit real information. Well, no, why? It's because it's not a real thing. It's not really happening, that's why. So it's like it's like the psychic who said, I can't predict the lottery numbers because it's against the rules. What rules? Yeah, right. The psychic rules of psychic trueness. What? Come on. And this whole idea that, you can have some faster than light communication, but they can't speak any language. They can communicate faster than light, but they can't say anything. So they can't really communicate. So, catch 22. All over the place. I think this guy's like a Tesla fanatic or something, so who knows. But anyway, I won't, it's easy just to keep, it's so difficult to have this conversation, because everybody is so passionate. I know, I have to concede, I'm convinced I'm right. The evidence convinces me, though. Not because it's exactly how Tesla says it works. No. So I'm not, uh, you know, it's not coming from anything but the fact that it provides a logical explanation, and I like logical explanations. So anyway, I haven't watched all this guy's videos. He makes a lot of videos on photography, so I obviously haven't watched those. And he has these physics things, these little shots at physics mixed in. So anyway, I just want to make this video I mean, it's only 6 dislikes. Well, there was only 4 the last time I looked. So anyway, it is going up. But I mean, compared to the rags I've done on Feynman, this is just a slaughter. And I got so much abuse because I dared, to pick at the icon, for some sloppy science. And ironically, I don't think this explanation of magnetism by Feynman was that sloppy in the sense that, yeah, he told a story to basically say we don't know. And that's what he did say in the explanation. He doesn't know why magnets attract. But he can explain what it can be and what it can't be in some sense, and give you a vague idea. But you also need to know some of these, you got to know some of the physics to understand what it is when something's transmitting or when an influence is being imposed. And so he mocked Feynman's virtual photon as an explanation that there must be some force that's creating the field, that's creating the effect. But it's not something you can take a thermometer and measure. You can only see the effect of the field's existence. You can't see what the field is made out of. And that's Feynman's concession. Where I'm arguing that the field is knowable. It is a real material field, and nothing does anything magical. Things do something very crude and kinetic and real, and there isn't any, I do this and you magically know what I did. There's no magical communication between any material objects. They must communicate with actual vibrations in the medium, the ether. And so this guy's kind of ragging on the whole idea of quantum. It's not quantum mechanics as, the woo-woo quantum mechanics of wave theory, okay, which I totally reject. Particles as this made up flibby-flabby stuff, photons going through 2 slits, all that kind of quantum mechanics. He's ragging on the very notion of particulate mechanics, the idea that there's a quanta, an essential particle, at the root of physics. And so that's where I would disagree with this guy's interpretation of quantum mechanics and just say, look, yeah, let's kill the wave nonsense, and understand that waves are byproduct mechanisms. They're not mechanisms in themselves. Waves travel through medium. They are not themselves something. They're made of something. All right, and yeah, and so you can't have a wave that's less discrete than the photon. That's the irony of their the standard model of interpretation, is that they've made the photon is already, even as a particle, was kind of a indiscrete particle. It's so small, so nothing, next to nothing, and yet it's producing an even more discrete, even more obscure, ultra mundane wave in front of it. And the wave has to be, waves, like I said, are part of thick mediums. Waves are always going through things that have matter in them. And the idea that you can have a wave means that you have to have a medium, and the medium has to somehow be less than the photons, which, is really getting, how's that going to work? Well, like I said, I make it work just because the medium's actually what photons are part of. Their medium, their ether, with a frequency. So anyway, so I'll see if I can provoke this guy into a conversation, maybe a video exchange of some kind on the general subject and what I find incomprehensible about his stuff, and he can give me a shot of what he, if he's willing to, read the website or, watch a couple of videos. Yeah, but you do have to invest some time to understand this stuff, and whether he's willing to make that investment, I don't know. My objection is okay. So he has a part 4. I watched that, and part 3, and so I'm trying to get up to speed on what he's talking about. But he, the whole, I'd have to play the video to show you. But I mean, he has just this a whole bunch of jargon, like hyperbolic, cohesive, something, you know what I mean, just a combination of big giant syllabled words tied together to say this is what's doing it, and there's no way you can exactly understand what he's talking about, and how that thing itself is generated. So you have this magnetic thing, and then that's causing the inverted electrical thing, and that's causing, and it's like, but how is that doing any of that? How are the atoms doing that? So it's not really a very good explanation. Where I think my polarized gravity explains magnetism quite adequately, in the sense that it's basically, gravity that is strong and weak, or black and white, and depending on whether you're black or white, you'll either be affected or unaffected. You'll either be repulsed, you'll be pushed away, or you won't be pushed away. It's all a push force, no matter how you look at it. There's no such thing as true attraction. Anyway, I mean, it's all getting pushed into something. Something's getting pushed. There's no pull. So anyway, I think that's, I don't want to make another generic video just going through the basics here. But I mean, the idea is that, yes, we have this kinetic field of quanta. They make a gravity that's basically a shadowing gravity. And because all the interactions are kinetic, there's no energy created or destroyed in all the interactions. The only thing exchanged is directional information. And it's basically a bunch of filtered directional information that defines reality. And there is no bent space, there's no curved space. The convergence that creates gravity is just a pressure gradient of chaos. A bunch of arrows, a bunch of things moving, bits. And that if you put enough bits in a thing and they're moving, it's automatically going to create a pressure, and that no matter what you put in any place in that field of little BBs bouncing around, BBs are going to hit it from all directions. Essentially, so it's going to be under a constant pressure of impacts in all directions. Anyway, and that's the pressure, that's straight line pressure, that creates all the other, that creates the tendency for things to be pushed together because they'll shield each other from pressure. So that basic concept is what the universe is built on, is the idea that if I put two entities in a pressure field where all the pressure can only move in straight line vectors, so it can't go around a corner, can't fill the voids like normal water pressure or something, or air pressure. It fills the voids. Well, if it can only move in straight lines, that two things next to each other will just be pushed right together. So it's just the idea of straight line vector pressure will automatically create the concept of gravity. So that's the simplest explanation of the basic dynamics. And so anyway, I just want to make a defense of quantum, the idea of the universe being built out of some essential, fundamental bit with simple, basic properties. And I want to defend, just a rational perspective on who Feynman was. He was smart. He was more than just charismatic. He he had a point of view that was sort of well, look, it's a deterministic universe, and in a sense, the environment created him, and people were rewarded for keeping physics mathematical, special club, only us people in the know, kind of thing, and there was a lot of that going on. I mean, E equals mc squared, Einstein came up with some very simple concept, but everything else Einstein touched was convoluted and insane in terms of its incomprehensibility, in terms of there being no mechanism, no capacity to see it. Where I could see when I heard E equals mc squared, it just was like, that's just obvious. That energy goes into matter and the energy is still in the matter. Duh. All right. It was obvious in the sense, obviously I grew up after the bomb, and so, once you see the bomb, then the E equals mc squared thing is really obvious. So, I mean, Einstein said it before there was a bomb, so that's a little more impressive. But, obviously, it still seems to me that it's something that they should have been able to say much earlier than they said it, just in understanding the fact that there's all this energy in the breakdown. You can break down matter, material forms, and it always ends up releasing a lot of energy. Burning something, for example. Anyway, don't want to get too far afield. Anyway, so I just found it weird that I'm going to come to the defense of Feynman. And the fact is, he did make some real contributions in the sense of simplifying, some of the thermodynamics, or some of the energy interaction between photons and electrons in Feynman diagrams. But some of the stuff was a little cartoony, like his turning clock thing for doing the probability analysis, which was just a way of saying how far something traveled. So he just used a metaphor of a clock, but the clock really just represented distance. And I just thought that was kind of a cheat, because it really was about distance. Something moves, not time. But anyway, don't want to get into that. So I have a lot of criticisms of Feynman's basic theology. Okay, models bad, math good, where I think models good, math good too, but math full of irrational numbers and all this set math, I don't know if it's so good. Anyway, so we'll just see if I can engage in a conversation where there's some, he has a theory, I have a theory. See if I can do anything to get, see what happens just in an interaction, see if there's any way he could explain his theory in terms I can understand, or I can explain my theory in terms he can understand. And see if there's anything called a real good criticism. Where, like I said, I think his critique of Feynman was just way too personal. It didn't have anything to do with the science, just had to do with stupid things, irrelevancies. And they were kind of dishonest critiques of Feynman's see, I'd like to say that Feynman was kind of thorough, but he wasn't, in so many subjects. But he had a sort of, his tendency was not bold, claiming anything. That, he was more, like, some people said it, I mean, he was more a mathematician than a physicist. And, yeah, that's sort of the truth of it. He seemed to have more respect for the model that created by, the crude description in terms of some sort of amounts of inputs, rather than understanding what the model as a mechanical model. So anyway, but that's enough said. Yeah, I mean, I cut Feynman some slack just because every now and then he said a single sentence that was worth something, that made all the difference. And so this guy's critique is that Feynman blah 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 blah. But you know, he read all of Feynman's books and all this. Well, if you've done all that, then you know that Feynman did state that, yeah, maybe it's all reduces to a checkerboard. You know, maybe it reduces to a fundamental, you know, mechanism, and that it's just the fact that it is so. There's so much of it, and it's so very small that we just can't get there from here. You know, that we're never going to be able to perceive it because it's too distant. But that it exists in that form, and all we can see is the implications of it on some bigger level that comes out as a mathematical abstraction. He didn't say it exactly like that, but that's what I'm just saying that he conceded to ignorance, and he conceded that it may be possible that all this mystery that appears to be in quantum mechanics wasn't really mystery at all. It's just that we're too distant from the mechanism to be able to see how simple it is. And I would argue that he just didn't it was there to have, okay? Because, I mean, I found it. If I could find it, he should have been able to find it. And it's just that he was too convinced that it would be more complicated than it actually is. And I think that's what he was looking for, a more complex answer, when the keep it simple, stupid would have been the appropriate approach. So anyway, it's sort of interesting that this guy is not being slaughtered. I mean, there are some people taking a couple of shots in the comments, but generally speaking, the comments are very positive for what was it, just a way over the top, 15 minutes of just a rag, not really any factual counter argument. Yeah, anyway. Yeah, that's enough. So, I'm just throwing it out there. See what happens. So I'll post a comment on this guy. I'll post a response to this video and see if he wants to have a conversation about physics. See what happens. Can't wait.